Okay, so we touched on deep time last time, even during that icebreaker activity where we were talking about those different geology quotes. And clearly this idea that Earth has an ancient history, very critical obviously for the development of geology, but also very critical for the transformation in our worldview as a society. What we'll talk about today in terms of the background for deep time laid the foundation for Darwin to do his work on evolution, and of course you all have an understanding of how evolutionary theory just revolutionized how we not only look at the natural world but our place in it. So important stuff, but historical stuff, and so you have to bear with a little bit of history to kick this off. So, I mean, this is, I don't want to go into this a lot, but, realize that before the development of kind of a modern geological approach to understanding the history of the world, and even to this day, there are lots of traditions outside the sciences that talk about origins, different origin stories, and this is we don't really have time to do a cross-cultural survey of all of these, but I guess the main point I wanted to lay out here is that based on different traditions, people had very different ideas about the antiquity and origins of the Earth. Okay? So I think, I'm assuming that most of us have most experience with Judeo-Christian kind of background with a very specific creation story that in the past had been interpreted to lead to the idea of a very young Earth kind of situation. But there are other philosophical and religious traditions that talk about time unending, no beginning and no end to time, and so we have basically a very large range of how people thought about the age of the Earth and origins before modern geology. Probably one of the biggest names we need to cover is that of James Hutton.
Didn't he discover, wait, I forgot actually.
Yeah. Well, he's often called the father of geology. We're working back in the dead old white guy era, so we're very paternalistic, and we're basically talking about many of the early contributions being made by the people who had the luxury to investigate the natural world. Okay, so James Hutton, Scottish farmer, naturalist, not real wealthy lord type of farmer, but not poor peasant farmer either. Some college, university experience, went to study medicine and chemistry, went back to the land, basically lived in the late 18th century. At that time, there was a lot of interest in fossils. As a naturalist, Hutton would be exploring the landscape, the different landforms around his property, and I find it interesting that he from bringing his farming perspective to these questions. He has a very strong sense of the land and the kinds of forces that are acting on the land, and in particular, as we'll talk about, factors that erode and break down the land. And so, from his perspective, he was thinking about, well, what are the processes that might result in, some kind of restoration, because you can't just continue to erode the land away, because eventually there wouldn't be any land. So again, toward the end of the 18th century, he came out with his major work, The Theory of Earth, and we'll pull out some of the important ideas that he brought out, but I just want to give you a flavor of the kind of manuscript that he would be putting out. I think a lot of these watercolors that were the original plates in the theory were actually his artwork, so he's got a strong sense of the land that he's bringing to addressing these questions. The main idea that he put forward in Theory of Earth is this idea that we have these cycles that are continually rebuilding and tearing down and rebuilding and tearing down the landscape. And from his perspective, that was all driven by heat coming from the center of the Earth. So in some respects, kind of a very modern way of thinking about the rock cycle. Not quite the way we think about it today. We'll be talking about the rock cycle in more detail when we focus more on Earth materials. But these heat-driven processes from the Earth were basically creating new rock that would be uplifted, and then over time those continents would decay through the processes that we can all see if we spend any time out on the landscape, and that he was clearly familiar with, as a person who spends a lot of time on the land, with that transport to sea, and then deposition in the ocean, and then the whole process all starting over again, being driven by these heat-driven processes from the Earth. This was actually a big controversy in its day. There were the Neptunists versus the Plutonists. Okay, so there were a number of early geologists who essentially argued that we basically get rocks as a process of materials precipitating and sedimenting in ocean environments, hence the Neptune part of Neptunism. And so Hutton's ideas, in terms of his idea of the rock cycle, really stood in opposition to that. That no, this process was really driven by by these heat-driven processes. So we've got per magma, ad magma, from magma to magma. Okay, it's not quite ashes to ashes, dust to dust, but we've got this kind of idea of cycling. So there was, as I say, a lot of controversy back and forth about this. When we think about it, it's not like it's all one or the other. And so when we talk about the rock cycle, we will talk about rocks being laid down in water in response to sedimentary processes. But, early days, you're trying to figure out what are the important principles to drive this new field that we're thinking, about in terms of geology. Positions tend to be a little bit more, less nuanced, more black and white, yes, no, Plutonist, Neptunist kind of approach. Probably the biggest, most important concept that came out of Hutton's work, though, is this idea of uniformitarianism. And so, what do you expect that to mean? Besides reading it off the screen. Okay, if you hear someone saying uniformitarianism, thoughts?
I was just going to say the same.
Okay. I mean, the main idea here is that the geological processes we see today are the same geological processes that were acting in the recent past, and the same geological processes that were acting, in the farther distant past. A very simplistic way of thinking about that is this catchphrase here: the present is the key to the past. So we see mountains eroding today in response to the hydrological cycle and rainfall and water falling down and freeze-thaw cycles, and those mountains eventually erode off to the sea. From a uniformitarian perspective, we would say that essentially those same processes were happening in the past. And so, however old was, we had mountains eroding back then, and we have mountains eroding now. We have to have processes that raise up mountains now, and those are the same processes that led to mountain building in the past. In antediluvian days, the world didn't work substantially different than what it works today, is essentially what's being talked about there. And this is a very important point because, if we don't make this assumption that the world worked in the past the way it works now, it really limits the ability of us, our ability to reconstruct what was going on in the past. Because if the world worked differently in the past, and we don't have any access to the past, then we essentially are saying we have no way of understanding how the world, worked. We have no way to test it. It's the same thing that astronomers and astrophysicists use, the same kind of theory. We understand how chemistry and nuclear reactions in our sun work, and we have to assume that it's the same kinds of processes that are going on in these stars that are 100 million light years away, for us to be able to apply what we know from our experience to understanding these areas that are further away. Corey?
So that's what Hutton discovered?
Yeah, well, discovered, promulgated, promoted. I mean, you have to remember what societal framework he's working in. In terms of Scotland in the late 1800s, we're essentially talking about a Judeo-Christian kind of understanding about the world. We're talking about an estimate driven by analysis of biblical passages that says, the world was created in 4004 BC. Ushers, yeah.
Then how did he think about the concept of deep timeline?
He had to break out of that mindset, right? So his experience on the landscape, seeing how long it would take mountains to erode and sediments to accumulate, and to go out and realize that, I'm looking at places that represent tens of meters of sediment that have been laid down and compressed into rock over time. You're not going to do that in 4,000 years. So clearly the Earth is older. And that's basically what this deep time concept is all about. The Uniformitarianism is somewhat in opposition to this idea of catastrophism. If we think about the Grand Canyon, we've got this huge hole in the ground. If the world's only 4,000 years old, the only way we could have scoured out that Grand Canyon was there had to have been some huge catastrophic event, some massive flood, which shows up in a variety of traditions, and the Grand Canyon was created catastrophically. And Hutton's saying, no, we've got more time than that. We have time for the processes we see today to be the processes that, Hutton didn't see the Grand Canyon because he lived in Scotland in the late 18th century. but the same kinds of landforms that clearly would take long periods of time. You either say we don't have a lot of time and we do all of this stuff catastrophically, or we've got all the time in the world, and the slow, gradual processes we see today are what created those in the past. Now, we have a more nuanced view of uniformitarianism today than Hutton did. I mean, we understand that every now and then an asteroid comes in from space and smacks the planet and makes major changes in a short period of time. So there are catastrophes that happen from time to time, but we can understand them as natural processes with a certain frequency and range of magnitude, and basically that kind of extreme event, if you don't want to call it a catastrophe, but those kinds of extreme events can be folded into this idea of, well, the processes that are going on today or the processes that went on in the past. And we, occasionally have meteor and asteroid strikes today. Fortunately, not a lot of big ones lately, but the same kinds of things would have happened in the past.
Can we just shoot them out of the sky?
Well, if we can identify that they're there, and we can develop some more technology, and if my the company I'm a fanboy of, SpaceX, doesn't keep blowing up rockets on the launch pad, then yeah, we could. Yeah, what?
At least it was an unmanned rocket.
Yeah. No loss of life, but it's gonna be a problem for them for a bit. Okay, and he brought these ideas all together in this particular landform, Siccar Point, very famous. If if you're ever in the situation to go around on geological pilgrimages, this would be a place where you would want to go, because this was key to the development, birth of modern geology.
Was this in Scotland?
Clearly in Scotland. So, this is a kind of landform that Hutton experienced and tried to reason out what was going on. And clearly you can identify lots of different layers of sedimentary rock. You've got layers of a different kind of sedimentary rock, and they are vertical. Just as we looked at those layers at the Site 3 in our walkabout on campus on Tuesday, where the layers were not horizontal layers. So Hutton would look at this and he would say, reason out that we must have had an incredible amount of time to lay down all of these layers of sediment. And then not only that, after that, something happened to squeeze and upend those layers and then shave them off. And then we have additional layers being laid down. And those aren't quite horizontal either, so this tilting has continued to happen. All of that has got to take an incredible amount of time, and so the world has got to be older than 4,000 years, and these gradual processes have got to have been going on for long periods of time. And that's the mindset that allowed basically modern geology to develop. Okay. And I've kind of alluded to this. The work that Hutton did was directly related or allowed Charles Lyell to, in the early 19th century, come out with his principles of geology, multi-volume, here's everything we know about geology kind of set. And these are texts that Darwin took along with him when he went on the voyage of the Beagle. And this idea of uniformitarianism and deep time and ancient Earth were critical for Darwin to be able to explain the patterns of diversity that he saw, and relate it to gradual, slow evolution of life in response to environment. So without Hutton and Lyell giving Darwin the kind of deep time framework for the Earth, it's not clear that he would have, out of those same observations he made on the beagle, come up with his theory of origin of species.
They gave him a lot of credit.
What?
They gave him a lot of credit without these two guys.
Yeah.
Seemed like.
Yeah. So, all these are parts of this transformation of our worldview from, you can go back further and add in the Copernican revolution, which, took Earth out from the center of the universe, made Earth and heavens part of the natural world. Now we have not only, this larger natural world to understand, but we have now deep time. We've got an ancient history of Earth to understand. All of this basically promotes, during the Enlightenment, and beyond, this inquiry that has led to our modern view of the world and our place in it. Just a couple of slides on one other guy, William Smith, who also had a major impact. He's working in the early 19th century, so the early 1800s. He is an engineer. He's in, at this time, England. I guess it was England at the time, or maybe it was Great Britain at that point, I'm not sure. But at this time, England is industrializing. It is tearing up the landscape, putting in railroads and canals. It's focusing on transportation systems, trying to modernize industry and agriculture and so forth. And Smith was part of that as an engineer. And this got him out into the landscape, into the countryside. And as we'll see when we go out on some of our field trips, there's no better way of getting an idea of what's going on in the earth underneath our feet than to have someone have an economic incentive to cut a section through, whether it's for a canal or for a railroad right-of-way, or putting in an interstate highway, and you want to not have to go up and down all these hills. You cut through, you can see what's going on. Again, there's a lot of interest in fossils, and Smith takes his experience identifying and correlating the different layers of rock sediment that he sees in different parts of England, and puts together basically a map that lays out all of that, essentially stratigraphy. And this stratigraphy that comes out of Smith's work is, I think it's fair to say, key to the early development of what we think about as the geological time scale. What layers of sediments occurred in what sequence, and what does that tell us about the past world? And we'll talk more about that next time and in the lab. Yeah. So he basically published this as a map. It was self-published, and this book is about the map. And I think this is cool because the jacket for the book is a copy of the map. And so he basically had mapped all of the geological strata that could be recognized by these canal cuts and railroad cuts and so forth across England and Scotland and Wales, and put it all together into, first of all, a map that shows what strata are at the surface in the different regions of England and Wales and Scotland. But also on the basis of that, he inferred how the layers must be arranged. If you would go from a transect from one side of England across to the other, and so he could essentially identify all of these different layers, realize that they had clearly initially had been laid down one on top of the other, had been experienced some tilting and erosion, and that is a skeleton of the story of England as an island and how it came to be. So, this map that he published and his analysis of the stratigraphy basically again provided that foundation for a lot of clean after.
Could the tilting have come from the Isles collision with North America?
Yeah, it presumably did. We'll talk about that more in terms of what's going on in the Northeast out here. But if you think about New England and New York area, we're essentially the bumper of North America, and we've been involved in collision after collision after collision, and that's why the geology is so interesting around here. But yeah, those kinds of processes would have been involved here as well. Kind of an interesting story. He was, somewhat a self-made man. He was an engineer. He wasn't rich. He had to self-publish this. Was not, necessarily a member of the Royal Geology Society. Didn't necessarily mix with the aristocratic crown, and his map got scooped by someone who didn't do as much work but kind of stole some of his work and was a better known geologist, part of this aristocratic group, and basically sales of Smith's map plummeted. He went bankrupt essentially, and what happens to people who go bankrupt in the early 1800s in England? Debtor's prison. So he was in debtor's prison for, I don't know, months or years until he finally got out. Was so disgusted of the whole political, aspect of how he had been basically treated by the geology aristocracy. Went out to the country to live, went back to being an engineer, and it was only later in life that people really came back to realize the contributions he made, and eventually got back into the London geology circuit, but clearly was bitter for a while.